Hello and good day everyone. I'm Hidis Calib A of BSCS2C in CBSU Imus campus, and this is my entry for Battleground script structure number 2. Today, I'm about to discuss the topic that I choose, cryptography. Using the three major methods, the ship cipher, the modulo operator, and the Vigenère cipher. But for that, let's define first what is cryptography. Cryptography, the word cryptography comes from the Greek word kryptos means hidden and graphy means writing or hidden writing, or in a rapid definition, it's a secret writing. Cryptography is the practice or the study of techniques for securing communication, information, data in an unreadable format for the unauthorized user. Cryptography protects the content of the messages and the letter. So it keeps the letter safe for the intended receiver. Also, cryptography is the most common components of security in today's time. But do you even know that even before the computer was born, people are using cryptography in their messages? So let's go back to the Old Kingdom. Old Kingdom in Egypt was the earliest known use of cryptography since 2679 to 2181 BCE, where scribes used it to conceal specific messages. And it follows by the Han Dynasty, the earliest recorded example of cryptography, 206 BCE to 220 CE. And one of the famous cryptographic system ever devised is the Caesar cipher, invented by Julius Caesar in the 44 BCE for personal use. And it's widely used today to protect sensitive information by hiding it within seemingly harmless texts. In the 4th century BC, the Greek historian Herodotus wrote of an encryption device used by the Spartans to communicate military secrets. And from there, cryptography has played an essential role in every significant technological development. And that is for the overview of our topic, cryptography. Now, let's understand how the cryptography works. So we have here a chart or diagram for us to easily understand how does it work. So we all know that communication consists a sender and a receiver. But we also notice here that there is an interceptor. So in order to prevent the leakage of the messages, so we have to do the cryptography or the encryption first. So look, here we have plain text and the sender do the encryption algorithm to make it decoded. So turn it into an unreadable format. So ciphertext. So plain text, encryption algorithm, and turn into a ciphertext. And when receiver receive the coded text or the ciphertext, he or she will do now the decryption algorithm using the decryption key that was given by the sender. So the sender do the encryption key and the receiver do the decryption key and turn it to a plain text. So again, plain text, encryption algorithm turn into a ciphertext. And ciphertext, decryption algorithm and turn into a plain text. So that is how the cryptography works in order to prevent the information to the unauthorized user. Now that we understand the flow of the message using the cryptography, let's now talk about the method, the three methods on how to encrypt and decrypt a message. So first we have the ship cipher. So what is ship cipher or Caesar cipher? Shift cipher is a simple substitution cipher where each letter in the plain text is shifted a certain number of position down or up the alphabet. Look at here on top, we have the chart of A to Z. So let's just ignore here the red thing and focus on the blue marker, the blue mark, the blue letters rather. So it's A, B, C, D, E, F, G, and so on. So it says that we shifted a certain number of position. The, here it's left and left or right, but it says down or up the alphabet. So it's the same. So from, let's say we shift 3. So let's says our message, let's say hate, hate or H. So we shift of 3. So 3, 1, 2, 3. So now the encrypted letter of H turn into a K. Sige, let's give more example. Let's say the A, right? The hate, so H, A. So A, with shifted of 3, we're just gonna count 3 steps. So from A, so B is 1, 2, 3. So A becomes D. Okay, so hate, so we're done with the H and A. Let's look at the T. So T shifted of 3, so we're gonna count 3. So U is the 1, V is the 2, and W is the 3. So T turn or becomes W. And E, so the last one, to the word hate, so H-A-T, and E, so from E, shifted of 3, so F-G-H. So E turn becomes H. So that's how the shift cipher works. So we're just shifted a certain number of position in the alphabet. So let's give more example. So this is more example. So we're done with hate. So now we're going to encrypt the love with shift of 4. So here I made uh, a alphabet so that you guys can see. So it's A again, it's A from Z. So love with shift of 4. That's the word that we are going to encrypt. So we're going to encrypt with the encryption key of 4, right? So 4. So from the word love, so L, so this is L, and L. So we're just gonna count four steps. So L, so start with M. So M is the one. M 1, 2, 3, 4. So the encrypted letter of L is P. Yan, so P. And next is the O. So this is O. So we're count 4 steps. So O, 1, 2, 3, 4. So S. S. And the V, this V, so let's find V here. And 4 step. So 1, 2, 3, 4. So the V become Z. And E, so let's count E. 1, 2, 3, 4. So I. And now, encrypted letter for love using the key shift of 4 in shift cipher is FSZI. So normal people can't understand what does it mean, not unless he decrypts. So yeah, so now we're gonna do the decryption using the decryption key. So in the encryption key, we count from the left, right? So it's shift of 4, so from the left to the right. While this is PSZI. PSZI. So PSZI, so this is our encrypted or the ciphertext. So we're gonna do the encryption using the decryption. So we're gonna do decrypt. So we're gonna decrypt it using the decryption key. So ship of 4, diba? Right? So ship of 4, yan. So we do it from left to right. Now, we'll do it from right to left. So P. So we're done P. So here's the P. We're just gonna count 4 backwards. So P, from P, so O, 1, 2, 3, 4. So L. So from S, we have R, 1, 2, 3, 4. So O. So yan. And Z. So from Z, let's count 4 steps backwards. 1, 2, 3, 4. So B, V, and I. So I. So let's find I here. So I, four step then. So H, G, 1, 2, 3, 4. So E. Yeah, so the difference is just we do it backward, opposite of the encryption key. So if the encryption key said ship 4 from right to left, so just like that. In decryption, we do it opposite. So we're gonna do it from left to right. If the encryption key is from right to left. So the opposite is from left to right. And after the ship cipher, we have the modulo operator. So what is modulo operator? So modulo operator helps ensure that computations stay within a specific range, preventing numerical overflow and supporting efficient and secure calculations. So in short, modulo operator, of course, from the word modulo, we're doing some mathematics. No? So we have the formula of y is equals to c plus k times modulo 26. So here, so di ba we're done with the blue marker. So let's now focus to the red marker. So in ABCD, I put a fixed number from 0 to 25. So we all know that the alphabet consists 26 letters. But here, we start with 0. So A becomes 0 and B become 1. So it is fixed number to the alphabet. So 0 to 25. But we all know that it was a 26 letter in the alphabet. So let's do let's have an example. Modulo operator. How we encrypt using a modulo operator. So of course, just like what I said, it's more like mathematical computation. So our formula here is y is equals to c plus k and mod 26. So 26 because we have 26 letters in the alphabet. But when we look at here, our fixed number here notice uh, the red numbers. So we have 26 letters in the alphabet. While here in our chart, we start to 0. So from 0 to 25, that's why it's only 25 because we started at 0. No? So yeah, so the fixed number of A is 0 and B 1 and so on and so on. So how does it work? So let's say again we have the plain text love. So yeah, let's say love. And we are gonna do the encryption. So encrypt. So here, so L, so let's find the L. L has a number of 11. So 11. And O, say O has number of has a value of 14. And V has a value of 21. And E has a value of 4. So let's say this, our K, so I forgot the K. So let's say our K is equals to, let's say 5 again. No. Let's say 6. Sige, let's say 6. Ano ba? Let's say 7. Let's say our K is equal to 7. So again, C plus K. So this is our C. The 11, the 14, the 21, and the 4. So 11 plus K. So 7. 11 plus 7 is how many? 11 plus 7 is 18. And 14 plus 7 is 21. 21 plus 7 is 28. 4 plus 7 is equals to 11. Yeah. So now, we have 18, 21, 28, and 11. So, 18 here in our chart, 18 is S. So S. So L become S. And our O is 21. So let's find the 21 here, B. So O become B if we encrypt it using the modulo operator. And V, so V, 21, 28 pala, 28. So we don't have 28 here in our chart. So that is the time when we are going to use our modulo operator. So yeah, so let's erase this. We already have the letter here. Again, V is 28, right? So 28 divided by 26. How many 26 in 28? So we have 1 and has a remaining 2. So don't forget the remainder because it will derive us in here, in our chart. So 2. So 2, let's find the 2. We have C. So V becomes C. So we're done with that. So E, I forgot. So our E is 4. 4 plus 7 is 11. So let's erase this 11. So 11, here is L. Now, the encrypted letter for love using the modular operator is SVCL. SVCL. So as you notice, the modular operator is like, we can actually just count. So let's say here, 28, diba, right? So so we have 28. Without using the modulo formula, we can actually just do it manually. So we're done with the modulo operator. So we have the last method, the Vigenère cipher. So what is Vigenère cipher? So Vigenère cipher is a method encrypting alphabetic text now by using a simple form of polyalphabetic substitution. So polyalphabetic substitution. Plain text is shifted according to the corresponding letter in the keyword. So here in Vigenère cipher, we use polyalphabetic. So here at behind me, we will notice the polyalphabetic. So poly means many and alphabet. So many alphabets. So here, many alphabet. So we just read alphabet. Yeah. Yeah. But here in Beginner Cipher, just like Chip Cipher, but we shifted the letter based on the keyword that was given. Let's just proceed agad here in our example because it's hard to explain the Wiener Cipher without the so again, polyalphabetic is a must that we can do the beginner cipher without it. Okay? So let's try. So let's have an example. So again, we have the plain text. So let's say we have a plain text of chocolate. So the sender wants to send the word chocolate. And we have the keyword of uh we have it. So it. So this is the encryption key. So it. So it said in the definition, we are shifting the plain text to the corresponding keyword. So here, so let's we have the it keyword. So A T and just repeat it A T A T. So the just plot the keyword to the plain text. So we have that. Okay. So now we have that. So let's take a look to the polyalphabetic. So the x-axis is the plain text. So again, C. Okay, so let's find C to the x-axis. So C, so this is C. And let's now find the E to the y-axis. So C and E, so we have G. Okay, we have G. Here we have G. So we're done with C. And H, A. So let's find H in the x-axis and A to the y-axis. So we have H, just H. Okay, H. And O to the x-axis and y-axis is T. It's hard to find here. So we have H also, have H. And C to E, we have G. Okay. Also C, we already have G, H, H, G. So let's do the O. So O tayo. O to the x-axis and A to the, so just O. And L, yan L here. L and T. L and T. What letter do we have? To L and L. So just cross it. L and T. So do we have E? Yeah, we have E. So we have G H H G O E. Everything. So A. Now A. A and E. So just E. Tama ba? Yeah, that's right. This is right. So LT. So AE. So now TA. T and A. So just T and ET. So from E and T, cross it to T. So we have X. So yan. So now we have the encrypted word for the chocolate using the Vigenère cipher with keyword of it. So we have the GHHGOEETX. So now, normal people that will have this word, the GHAGOEETX, can't understand what the sender wants. So let's say the intruder is don't know what's the keyword. Not unless he knows the key. He might know what is the plain text means. So the important thing here is the keyword and the polyalphabetic because you're going to cross it using the polyalphabetic. So now let's do the decrypt. So yeah, so let's erase this. Again, we're done with the encryption. And now do the decryption. GHH, so just rewrite it here on top. OGEETX. Yan. Just write it. Again, our keyword is it. So decryption and encryption have the same keyword. So it, just it. Now, let's focus here muna in the keyword. To the keyword. So it. So first, let's find the keyword to the y-axis. So we have e, right? So e. So from the line of e, find the g. So e and find the g. So what is the and look up on the top. Yeah. So here. So what is the letter? So it's C. So now we got, again, we turn it into a readable format, plain text, chocolate using decryption using the it keyword in Vigenère Cipher. And yeah, so that is how the three method works in encrypting and decrypting a message. So a ship cipher, the modulo operator, and the Vigenère cipher. So again, I'm Helios Jen Calib A, and my topic is cryptography. I hope you learned something from me today. That's all, and thank you. Bye-bye.